This is CIS30A Part 3 of Week 3 lecture. And in this part, I will talk about module. So module is a portion of the program or an extension file that can be imported or invoked through other program. And in Python, we would use import keyword to bring in the module. And in the last video or the first video, I talked about using collections for deck. So in this part, we will create our own module or create a custom module. So now in a module, we would have Python statements, definitions, most likely we would have functions, sometimes we would have classes. So a module can contain various things from classes to variables to methods. And so what we can do is we can import necessary modules, either built-in ones or the ones that we create custom module, to be able to build a larger program. So this is why modules are important, in that you can edit the module and only gonna be impacting that portion of the program compared to having to change the entire program itself. The same concept is applied if you're looking at packages or Java packages. So module can be used for various functions and tasks in a program. So here it gives you additional information about modules, and what we can do is, the important thing that you need to remember is that your module needs to be in the same folder or the same directory as your program when you run it. So when you store it or when you package it, it needs to be in the same directory or the same folder. And so what happens is, after you build the module and you run the program, it created this folder called PyCache. And inside the PyCache, once a module is created, it's going to create the CPython file. And it's going to also contain your module name, and the file extension would be CPython file. And so here it talks about how that is used with the Python path environment variable to be able to execute after the extension file is compiled. And so that's what you see when you look at the module that you create. You would see the CPython, and it would have it cache. And we can also use the same module for multiple programs as long as we store it in the same folder or in the same directory. So now what I want to do is I want to show you the example module that is written. So here what we want to do is we want to create our own custom module to operate arithmetic on two numbers, basically adding, subtraction, multiplication, and division. And we would call this calnum module. Okay, and so the reason why I have it print here is I wanted to show that it's ran. If you don't have a print method or a print statement, what will happen is, even though it's ran, it's not going to confirm. And we don't have to have a print method every time we create a module, but for illustration, we have a print method, and we wanted to show that, the module has been created. First, we have a function called add, and with this function or the method, we would have A and B, and we wanted to store the result of A plus B in result. So A plus B, the output of that will be stored in result. We would return it. Then we have another function for subtract called sub-t, and we would store the output for A subtract B in result, return result. And then third is mult for multiplication of A and B, stored in result and return it in result. And then lastly, div for division of A and B. A divided by B is going to be stored in result, and we're going to return it. So once we write out our statements and our functions here, we're going to go ahead and save it as the module that you want to call it, any name that you wanted to call it. So in this case, we're going to call it cownum. And then once we save it, then we're going to go ahead and run it. So once a module is ran, this is going to actually show us because we told it to print. And as I mentioned, what happens is it creates a PyCache, and then inside it, it would have the CPython here. Okay, the CPython file. Once I have that created, then what I'm going to do is I'm going to write a program that's going to import in the module that I just created. So in your notes, what you see is the example of that module is located on page 11. Then next, for our program, we're going to import in that module that we create, which is on page 12. So here is my example program. And notice at the top, I have import. Basically, I'm going to bring in the content of that module to be used with this program. So I'm going to do import cownum, exactly the same name as how I named my module earlier. Then here I can simply call my function or my method that I have written in cownum. So once I imported it in, I can say cownum.add, which is a function that I previously defined in cownum. Okay, and then I can do sub-t for subtract, and in the parameter for add, I just simply put in the number. I give it the values that I wanted to operate. Same thing with subtraction, multiplication, and division. So when I run this example program, it brings in the cownum module, which should be stored in the same location, in the same folder as my example program. Then when we call the function, each of the function is called here. I have 91.5 for the addition. Subtraction, I got 6, which is 10 minus 4 is 6. 5 times 8, that's 40. And 100 divided by 2, I get 50. So here you can see that we can write our module, create a module, have functions defined, and store the result. Then we would write the example. Then we would pass the values, call the functions after we import in that module. And that works. An alternative way that we can also use the module is, what if I wanted to rename it and I wanted to only use it for, I wanted to call only one function instead of all of it. You can import the entirety of the module, or you can also use as and then use an identifier for it. So here I import cownum as cnum, and then I can use that name, how I renamed that module, and call on the div method inside that module to operate the division. So when I run this, it's still going to bring in the cownum, but it's going to rename it as cnum. And then it's going to take 4 and divide it by 12.6 and return the output and show that because I issue a print here. So I call the division method using a new name that I gave to cownum, the module that I created. So this is an alternative way that you can do this. And you would see a lot of example that uses something like this. And another way that we can import part of the module. In this example, we would have from, using the from keyword, cownum, which is the module that we created. We're going to import in one of the function, which is div, and we're going to rename that as dnum. So you can bring in only one of the function or the method that you have previously included in the module and then rename it as dnum and use that. So with dnum, what we can do is we can take 500 divided by 100, but using a different function name in replace of div after we import it from cownum. So when we run this, we would have, I need to do a print here. So to illustrate this so you can see the output, I would have 500 divided by 100, I would get 50. Okay, so what it's going to do is going to build the module, bring in the div function, rename that as dnum, and then use that to operate the division from 500 to 100, which gives me 5. Another way that we can use the import is if we're not sure what we want to import, what we can do is we can say from the module, which is the module name, we can import, and then we can put the asterisk. Now, because instead of having to import in specific method or function, we can simply put an asterisk as a placeholder. What we're saying is we are going to use some of the function from that cownum after we import. So we're going to import in some of the functions from cownum module. So for the next part, we are going to use mult to multiply 5 with 10 and print that. And then we're going to do div for division 6 to 3 and then print that. So if you're uncertain on how the function would be named, or you can just simply use the asterisk there. So here what you have is the first is going to output 50. 5 times 10 is 50. And then it's going to output 6 divided by 3, which gives you 2.0. So this is a different way that you can use the module or part of the module using from and import keyword. And by practice, notice on page 12, I highlighted here that for efficiency reason, each module is only imported once per interpreter session. The reason why we did it a few times there for illustration was just to show you how you can import and also using from keyword. Therefore, if you change your modules, anytime that you edit your modules, you need to restart the interpreter and then you can import it. A way that we can reload it is to use importlib.reload or importlib. So this is a different way that we can reload the module, or you can also test it interactively. Now, a way that we can search the location of that module is we would use the CIS.path. Depending on where you place it, it's going to show your current directory and also the Python path. So to illustrate this, here is, you can use this with shell or in Tawny, that would be the bottom here. So I would go ahead and do import sys like this, and then I can say sys.path. So what that tells me is it's gonna tell me the directory of my current directory. It's also gonna tell me that from which python.zip and the DLL and the lib where it's accessing from, and also the site packages with this, as Tawny is using 3.7. So what we can do is we can use this to identify the location or the path of our file and our module file. So that way it would show you the actual path here. Now, in the notes, it also I'll show you how you can use dir method to find out the names that are defined inside the module. So if I go here and I say import cownum directly in shell, once cownum has been built, then I can do dir and it would list the namespace of the files and the packages, so including add, cownum, div, molt, supt, and see, these are the methods that were incorporated. So dir gives us what? Dir gives us the function to find out the name of the functions for inside that module that would relate it to that module. So what you can see here is that it gives us the functions, or the function name that would be in our module, and also the namespace that would relate to that module. So what you can also see there is that I show you the output for that as what you would see on Tawny there. And the namespace attribute simply contain the name of the module. So we can do import cownum, and then we would do cownum with the namespace. So this concludes my module. I will set up a few lab videos on how to write lab exercises module, so that way your program can run accordingly. So please watch those. And next is going to be file handling, which is going to be pretty short. So please watch the next part of the video. So in this part, I'm going to talk about, right now I'm going to talk about file handling. Similar to all the other languages like C, C++, and also Java, you can output file. And so in file handling, what we can do is we know that there are 3 operations that takes place in a Python file operation. We can open a file, we can read and write to the file. So if you have content, you can read and then you can write into the file. So you can add new content to the file and then we can close the file. So please make sure that you know these operations for quiz and exam. That's important. So 3 operations for Python file operation are open, read, write, and close. So to open a file, what we can do is we can use the open method or function. So using the open method, what we can do is we can, inside its parameter, we can give it a name. So if the file doesn't exist, it will create the file. So here in this example, we have F. F is open test.txt. So we would open a file in the current directory, and F is an object. It's going to open this test.txt file. If it doesn't have it, it will create it. We can also open it and set it in a specific path. Like we would find a file from a certain location. Specify the full path. So if you have a file in a certain folder in a certain drive, you can also include the path inside the parameter. Now there are different modes. So we will have R for read, W for write, and A for append. So in order for us to set the file to a certain mode, what we can do is we can do an open.txt to open and read the file. So in order to read, you have to open the file. So when you open test.txt, it's going to be equivalent to read. You can also write, set it to write mode as the second field parameter here. So once you open, then you can write. We want to be able to open the file and then set the mode, like write. So in order to write, you have to open the file. We can also write it this way. Open the text.txt file. The mode is going to be R and the encoding is going to be UTF-8. So here on page 14, it shows you how to, or the list of modes and its description. Read opens a file for reading. W opens the file for writing. Creates a new file if it doesn't exist. X opens the file for exclusive recreation. A for appending, and it's going to go to the end of the file without truncating. Creates a new file if it doesn't exist. T for open for text mode, B for binary, and + opens for updating. So those are the different modes that you can use. And when we're done with the file, we then would close the file using the close method. Okay. So after we open, then we can close. So in any case, when you wanted to finish, then you would close the file and that would exit out of the file. So now what I wanted to do is I wanted to show you the example that's used for file. So in this example, I have an object file, and it's gonna store it is my file.txt after it's open and written. So what we're doing is we're opening my file.txt. We're gonna write to it, and that's gonna be residing at the memory location of call file. Then when we write, we are gonna write I am a student in string. And note that when we write, it's going to go to the beginning of the document. It's going to add this. And then next, on the next line, we are going to write, I am learning Python. And then we're going to close. So when we run this, nothing will appear in shell. But then if I go to the location of the folder where my file is stored, I would look for my file.txt, and when I open it, I would see I am a student and I'm learning Python. So when you write to the text file, the first line here is going to be at the beginning of the file, and then it's going to follow that with the second line. What if I wanted to write to the existing file that already have several lines? Then I wanted to make sure that my cursor is placed at either that location or the next line following that line. So I want to make sure that I have the number of characters in the parameter that would point to the location of where the cursor should be in that file. So otherwise it would then again, once we reopen the file, it's going to jump back to the beginning of the file and start writing over your existing text. So as you have existing text, you're going to make sure that you have the location of your cursor where you want it to be to add additional text to that file. So to follow that in this example, again, I'm going to still use my file.txt, which is what I used in the previous example where we put I am a student, I'm learning Python. I wanted to add to that. Or I wanted to go to that file and read the lines. So in this program, the next program, I'm going to open up my file.txt, and I'm going to go ahead and do a read using read mode. And then I'm going to print the entire length, which is the string. While we're using length here, that's going to be the entire string after I operate read lines from the file. So an important note is that when Python read all the lines, the cursor is going to be at the end. So we have to bring it back up to the first line to read the first character. So to bring it back up to the first line, we're going to have to do a seek 0. And when we initialize words, we would initialize it as 0. We would have a for loop. For line in file, words is going to be the length of the line with split. So here in this program, as you can see, what it's going to do is going to do a word count. It's going to print out the words as it's going to do a word count. and then it's going to close. So when we look at the file, let me minimize this. So when we go back to the position, we would then read. So we have 2 sentences. That's going to do a 2-sentence count, 2 sentences, the entire length. And then it's going to go ahead and count up the number of words that's going to be in this file. So 2, 4, 6, and 8. So it tells me that there is 8 words. So in this particular program, it reads the file. We send it back to the first position, which is 0 for our cursor. Then we're going to count up the number of words in the file and then the number of sentences in the file. So that's going to be 2 for the sentences and 8 for words. So for the example on page 14, 13, 14, 15, and 16, it shows you how you can use read method to read the first part of the data and the next part of the data, or read line. And with the read line method, it reads the individual lines of the file, compared to read method, where you can actually have it read to a certain size. You can read it to a certain part of that particular file, but for the read line, it would read to each individual line. And the method reads until the new line, so it's going to read each line. As what you would see, what we have for this, as we have 2 lines, and then when we do a read, we can do each line read right there. So it prints that there are 2 lines that are read. That's why you would show 2 here. And then when we did the for loop here, that counts up the number of words that it actually read. So that kind of gives you the overall idea on how that would use. And there are other methods that we didn't include in the example that would be useful for file operations. The table is listed on page 17. So before we end, I wanted to illustrate the last example, which is going to be opening my file.txt, and we're going to add more content to, we're going to add this line to the file, and then we're going to read it. So in this program, first, we're going to open my file.txt. We're going to use an append mode. And then we are going to write. I enjoy programming because it makes me think. Then it's going to come back to the beginning, and it's going to read that line. It's going to read from the beginning, and then it's going to close. So as we previously had the 2 example, I am a student and I learned Python. Notice that we're doing an A+ here. So we're going to add this line to our file. Then it's going to come back to the beginning. Let me reopen this. And as you can see, it added this line. After that, it's going to come back to the beginning of the file, and then it's going to read the 3 sentences, the 3 lines, and it's going to print that there. So we can write more to this. We can say file.write we can say Python is fun. Now, if we add another line to this, so I wanted you to see, we're going to go ahead and rerun this. As we didn't add a new line, as you notice that it just appended right after this. So if we wanted to add a new line, we just simply use the /n. So with the last example, you can see that we appended this, and then we can also append the next line if we're adding the new line. So with that would conclude my illustration for file operations. So in this video, we cover modules, and we also cover file operations, which are two important elements of our course project, and also you need to cover the content for final exam and quiz. Thank you for watching the videos. I look forward to seeing you in the next video, and if you have any questions, please let me know.